Well, welcome to my shop. I'm Earl. This is Earl's small segment shop. What I'm going to do today is make a real quick, small video. What I want to do is do a little shop talk and answer some of the things that viewers have been asking from time to time. Some of the things I've gone over, but apparently I'm not good enough at making them clear. I don't know. Guess I'm not a good enough teacher. But I'll try and explain some of them that I've been asked. Of course, I might miss some of the things I've been asked. One of the things I've been asked many times is cutting segments. And this is an exaggerated segment. So, now a segment, this is considered the height. That gives you the height of the segment if it's a closed segment, or the height of the segment if it's an open segment. This is the cut length. This is determined, of course, by the size, the diameter of the ring, and the number of segments. Now let's say, for instance, we are 20 segments per ring, closed ring, and we want a 10-inch circle. This dimension right here, across here, would have to be 1.58 inches. And of course, this dimension is called the width. Now the width is the dimension that is hard sometimes to figure. If you have a turning that's fairly straight sides, not much curve at all, then the width is mainly determined by the wall thickness. If you have a drastic angle, then you've got to consider that in the width. I made a drawing here, well exaggerated. If you got a fairly straight side, the width is basically just big enough, the segment has to be big enough just to cover the wall thickness. Of course you want a little bit extra for a slop, but if it's angled, it's got to be big enough for the angle to go through. So that determines the width. Now most of the turnings I've been doing lately, 90% of them, they're pretty much straight. So what I do is just cut off the edge of the material, just cut the edge off, and use the edge here as the width. That way it gets rid of a lot of waste. And of course, all the boards are not exactly the same thickness, so the width will vary. Sometimes I'll get one that's too skinny, and I'll have to cut it different, but most of the times, that's how I cut the width. If I make a turning once in a while with different angle, I'll have to cut the wood different. Yeah, I'll have to cut a big piece out and use that. Okay, so when you're making a solid ring, you can cut the pieces. They don't have to be perfectly smooth. They got to be about the same. I used these to cut the last ring I made it from many different woods. These are all basically the same height. They're not perfect. They're close, real close. And basically the same width. Again, they don't have to be perfect, just close. And glue them up into a ring after I cut the segments. On the other hand, if I'm cutting open segments for an open segment turning, they all need to be the exact same height. They all have to have one smooth surface for gluing. Now what I do is cut them a little thick and run them through the Drum sander. Okay, so not everybody has a drum sander. You can run them through planer. That'll work. If you don't have a planer, then take this here, Gunkel Owls. What I'm going to do is make a couple of strips 1/2 inch height. So I run this across the joiner to get one smooth edge. I'm going to also make a strip of bloodwood, and I run it through the joiner, make one smooth edge. Now what I'm going to do is rip a 1/2 inch piece off. Now, I can use a bandsaw, I can use a table saw. I cut 2 sticks off, ripped them. They're exactly the same height now. They got one smooth side. It's been run through the joiner. The other side, a little bit rough, it's been ripped. So this is the side I need to glue on when I glue the open segments on. So what I'm going to do, just take my wood marker, you can get these at the big box store, run a line down the rip side. So when I go to glue them on, I'll know which side to glue. Easy as that. And this one too, oh, this one's red. Okay, I can use a black marker on it. So that way I can identify which side to glue. Now, of course, if I'm going to use maple or whatever, I can do the same thing. Rip it and get one good glue side just by using the joiner and ripping them. And then cutting segments with them. Of course, after the segments are cut, and after you glue them on, you're going to have them on like this, and you're going to have the marks on each one. But they've got to be sanded flat anyway. That's why they've got to all be the same height. So I got to put a sanding board on them and sand them flat after they're glued up. So that's one way of doing that. I've also heard, someone told me, they've got a good glue line rip blade on their table saw that they can actually rip a surface good enough to glue. I'm not going to verify that. I can't verify it, but I got to take their word for it. If it works, great. If it don't, well, I don't know. If you don't have a good, smooth enough surface when you go to glue on open segments, they won't stick. You got to have a good flat surface. Okay. So, use the drum sander to flatten segmented rings after they're cut. You can, if you happen to have one. If you don't have one, you can use a drum sander. Now, excuse me, not a drum sander, I'm sorry. A disc sander. Like this. I can put this right up against a disc sander. If you don't have a disc sander, or if the ring's too big, you can always put it in the coal jaw, turn it flat, and then use the sanding board on it to flatten it, completely flatten it. I do that a lot. It gets it really flat. It gets it flatter than the drum sander will. The drum sander actually won't get it that flat. It'll get it flat, but not that much. If you can't do that, there's one more alternative. You can build one of these that screw right onto your lathe. This is just a common nut. This is a 1x8. Now my lathe is a 1 1/4 by 8, but I got a 1x8 adapter because some of my old chucks are 1x8, and a lot of my homemade stuff is 1x8 nuts. You can buy a 1 1/4 by 8 nut, but it's a little more expensive. You can get these nuts in a farm supply by the pound, and they work good. You can make one of these. I got a video on how to make one, very easy to do. And it works great for flattening a segmented ring. Another big thing people keep asking me about is gluing. My 15-minute cure time. A lot of people have a hard time accepting this. I went to a club meeting. I was demonstrating. During the demonstration, I had 8 pieces cut off. Actually, they were old segments, pretty big ones. And I glued them together. They all had a good flat surface. They all had a good flat surface, long grain, flat surface that fit together good. And I was using Tite Bound 2 then. Now this works with Tite Bound 2, Tite Bound 3, Tite Bound Quick and Thick, which I like to use now. Dried, it's got the same properties just about a Tite Bound 2, but it dries clear and it's faster. So I like it now that they've come out with it. But I glued 2 pieces together, made 4 sets there at the club meeting. And I asked one of the members if they'd give me a 15-minute time hack. After 15 minutes, I passed the sets around, asked them to pull them apart. Well, one gorilla they had did pull them apart, but they didn't bust at the glue line. He broke the wood right next to the glue line. So, yeah, if you have any doubts, take some pieces, make sure they've got a good, smooth, tight fit. I don't care what kind of wood they are. Make sure they've got a good fit. Put a little bit of glue on them. You don't need too much. A little bit of glue on them. Smear it around good. Make sure it's all covered real good. Rub them together. Leave them set for 15 minutes and then try pulling them apart yourself. If your shop's normal temperature, 15 minutes is good. If your shop is cold, real cold, may take a little bit longer. But 15 minutes should be good. Just rub them together. 2 pieces of wood, similar woods, dissimilar wood. As long as you've got a good tight joint. But that's the thing about segments. You want a good tight joint anyway. Just glue them together and let them sit for 15 minutes and then try taking them apart. And decide for yourself. That's easy enough to do. You can't get them apart if it's a good joint. No way. So, I hope that explains that well enough. Actually, you know, I'm still going to get questions on it. People still have a hard time believing it when the manufacturer says you got to let it sit for 24 hours. The other day I seen a post where somebody had made a real nice clamp press for segments. Put the segment rings in and press it down. Nice looking. When I first started doing segments, I made a press. Wasn't that nice looking, but it was pretty effective. And I used it a couple of times, and I threw it away. You line the rings up, start to clamp them, they slip and slide and turn. I found out, real quick, a much easier way. You mount your base on the lathe, you put your first ring in the cold jaw, bring it up and clamp it where you want. It's self-centering. If you put it in the cold jaws and the tailstock, it's self-centering, and you can line it up like you want. 15 minutes of glue sets. Now you can turn it, or you can put glue on the next ring, glue the next ring up. 15 minutes, glue the next ring up. Let them sit for 24 hours if you like, but I guarantee you each one is going to be perfectly centered and lined up just like you want it. So that's just one of the little things I do. About the shop, my dust collector, I got tired when I first put it in, running over and turning it on, turning it off. Now they got remote controls they sell for dust collectors. Rather expensive. I couldn't afford them. What I could afford was the Christmas tree light controller, rather cheap, awful cheap. Of course, they're not strong enough, they won't carry enough current for a dust collector. But being I've worked in electronics all my life, I had a couple of big relays laying around. And the Christmas tree light controllers are strong enough to turn on the relay, so I used a relay to run the dust collectors. Well, of course, after years of doing it, the points burnt, you clean them up, they burn again. Eventually it gets to where they're sticking all the time. So here recently I took the relays out. For $11 I bought a solid state relay, 40 amp, that's plenty of current handling capability, 380 volt. And for $8 I bought a heat sink for it. So I put the solid state controller on, and it takes very, very, very little, minuscule amounts of current to set it off. So, my Christmas tree light controller, solid state relay. Works perfect and cheap. So at the same time, I got my music system. Now, my music system, I don't like listening to the radio, hearing 5 minutes of commercial to hear 2 minutes of song, and usually not the song I want to hear. It's the right kind of song, but you know, if I want to listen to country, I want to listen to old country. It's hard to find. So when I was working, we had in the shop, we had a problem. Everybody wanted to listen to different kind of music, always fighting over it. So the boss told me to write a computer program that would play MP3s, and everybody could put their MP3s in, make a list, make 2 lists, whatever. They could put their names on the program, couple their names to a playlist. They can change the playlist anytime they want, of course. And then if they're in the shop, a little checkbox, check that they're in the shop, and it'll play their song, then it'll go on to play the next person's song, and round robin all day long, whoever's in the shop. So I wrote a program that did that, and then the next thing I discovered is that some MP3s are recorded real loud, some you can barely hear. So that was a problem. So I wrote another program and put in it that would bring up the level of the low ones, bring down the level of the loud ones, make them all the same. Automatic volume control on it. So after I retired, I took that program. I like it. I can play my MP3s all day. I can load, 18 different playlists in there with check boxes, because I'm the only person. And I can play whatever I want to hear. Just check it and it'll play that. If I want to hear 2 different playlists, check both of them and it'll rotate between them. And then I hook it to an amplifier out of my computer, of course, to the speakers. But when I'm recording, I got to run over and pause it, record, and then run back and unpause it, back and forth. So I wasn't listening to music most of the time. So I got another Christmas tree light controller from a different company, so they won't interfere. Put a little relay, because it don't carry any current, on the output line from the computer, and now I can turn it off and on whenever I want. So I don't have to run back and forth. I want to record, I turn it off, done recording, I turn it back on again. It's been 15 minutes now. There's no way in the world I can take these apart at all. They're stuck together forever. Another thing I wanted to talk about was sanding, one of my favorite subjects, of course. I made a video recently on sanding. I took a really hard wood, bloodwood I believe it was, and I started with 80 grit, whether I needed to or not. I roughed it up with 80 grit to show how, if you got tool marks or if you got tear out on one, you need to take them out. Yeah, it takes a little time, but use a grit that's effective in taking them out. Don't start with something like 220 trying to take out tool marks. And then I showed how, just in a matter of just a very few minutes, I took it all the way up to beautiful, shiny, and then buffed it. Well, I have had questions, many questions about that. One of them is, do I buff everything? Well, no, of course not. Only buff really hard woods. Softwoods don't buff good at all. And sanding, if I have a hardwood, Purple Heart, bloodwood, something like that, and I also have softer woods, maple, walnut, and the same turning, I can't sand it very much. I got to turn it pretty smooth to start with. If I sand it too much, you sand away the softer woods, the maple, walnut, and you leave the hardwoods proud. It makes a washboard effect. So you don't want to do that. And also, open segments. You don't ever, 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 ever put an open segment on the buffer. Of course not. It's going to grab it and throw it across the shop. So yeah, and sanding is really very, very easy if you do it correctly. Very easy, very quick. I know I get a lot of gruff about that, but it's a fact. I don't know if I want to talk about tools today or not. I guess I could. The tool. Okay, the Olin tool. It uses high-speed steel bits, just like this, that are made for metal turning lathes. And people tell me, well, you know, they can't cut wood, they just scrape it. Can't really cut it. Funny thing is, and I'm still trying to figure it out, you put this in a metal lathe and it cuts steel just fine, but it won't cut wood. I don't know. That's I don't know about that. Same thing with carbides. Now, people tell you, well, carbide tools don't cut, they just scrape. But if you put the carbide, the same carbide bit, in a metal lathe, it cuts steel just fine. So, I don't know. I got a little video clip to see if I can find it, put it in here. It shows me cutting with a Olin tool. Now, I've been to quite a few club meetings, quite a few clubs, and people I've encountered, the majority of them, not all, the majority of them use the tool that they were originally taught to use, in which most cases is the classic tools. When I started turning, I got a lathe, I got a Harbor Freight lathe, and I couldn't afford nothing else. I went to the wood shop and they said, well, you got to have this tool and this tool and this tool. Each one was outrageously expensive, and then you got to have the sharpening system. It cost $200 or $300. So I couldn't afford any of that. Just forget about that. I got a lathe I ain't going to do nothing with. I got to looking and I found the Olin tool. Very simple tool. All it is a piece of steel and a handle made to hold these bits. And then the bits you can grind in any shape and any angle you want. So I made a few and I found out they work just fine. They work great. I've been using them ever since. It cost less than $10 to make a tool. At the time I started, it cost about $3 to make a tool. You can buy the steel rather cheap if you go to the ironworks. If you go to a big box store, it's a little more expensive. And then these bits, you can get them from Harbor Freight, you can get them from Amazon, you can get them from Grizzly. There are many places you can get the bits. And so, I'd been using them. Then I'd come out with a carbide bits. So I thought, well, let me give them a try. I made a set of carbide bits on a square shaft. That's what they come out with. Square shaft, you're taught to come in level with the floor on them. And they cut quite drastically. They're rather aggressive. Now, of course, they tell you got to keep it level with the floor and you got to hit it right in the middle. Well, the tool don't know where the floor's at. A lathe sure don't know where the floor's at. You can come in at an angle like this. As long as you hit it in a high spot, it'll cut the same way. If you get above it, you get a snag. If you get below it, you won't quite cut so good. But I found these quite aggressive. They cut great, but they were aggressive. So I put some on a round shaft. What if I put them on a round shaft? The round carbides are great on a round shaft. The squares ain't too good. The squares, if you angle them up to get a shear cut, you've got to be careful not to let the corners catch. If the corners catch, you're going to get a catch, no matter what angle you're at. So I don't use those too much. But the round bits on a round shaft, or the diamond bits on a round shaft even, are great. You can turn them, twist them in an angle, get a shear cut. I was at a meeting with a club one time, Saturday meeting, had a show and tell, a bunch of people turning, a bunch of people watching. And one of the members turned a little flat dish, maple, and he had tear out in it, and he couldn't get the tear out. I asked him if I could try, and he said, okay. I took a carbide bit on the round shaft, and I turned it up to about 80 degrees, and I made a couple of passes across, taking off real light cuts, took all the tear out, and he couldn't believe it, because carbides are famous for making tear out, which happens when you're on a square shaft and coming in flat. They're quite aggressive and a really rough cut. But when you twist them up and come across, you get a nice sheer cut, which is I found effective. Now, what's the difference between a carbide and an Olin tool? Really, the only difference is the metal. Okay, if I'm using a carbide bit and I'm on the inside of a bow, I'm going to be coming around like this. I'll be using the end of it and this side of the bit, the round bit. I'll be using the end and this side. If I'm turning the outside, I'll be using this side of it and the end on the outside, depending on what angle I'm at. And of course, if I'm doing the bottom, I'll be using right around the end. So, on the inside, I'm using this part of the carbide. Olin tool, I just grind it the same curve, the same exact curve. I got another Olin tool for the outside. This is part of the carbide I use on the outside. I grind another one this way. I grind one with a curve across the top. Same as using the end of the carbide. And of course the flat carbide's the same as just grinding this flat on the end. So basically it's the same tool. Only difference is the metal. The carbide, of course, stays sharp longer than the HSS. But I can take this HSS tool, the Olin tool, over to a regular $20 grinder I got from Big Lots, regular old bench grinder, and sharpen it in less than 10 seconds freehand. And eventually you do grind these down. Yeah, they last me a long time when you learn to use them, learn how to just sharpen them, not take off too much metal. And they're cheap. They're not that expensive. So I got a bunch of them ready to go. And I wear them down to really short. I put a, let me see. I put the nut, the screw, right at the very end, as close as I can get it to the end, and I make the hole where it fits tight, the smallest hole that I can get it to fit in. Now, of course, I don't have a full set of drill bits. I'm not a machinist. If I had a full set, the numbered bits and the alpha bits, then I'd probably be able to get an even tighter hole. But I got the tightest hole that I can fit in with my bits. My bits are in 64th increments naturally. So yeah, it holds it pretty good. Just one set screw right at the end holds it pretty good. And I can wear it down to almost nothing. And like I said, it cuts the exact same as the carbides. Of course, you can grind any shape you want. You can grind any angle you want. If you need something special, you can do it. You can grind the diamond point on it. So yeah. And the old timers will tell you, you can't cut with it. Like I said, I'm going to look and see if I can find my short video clip I got showing big strings coming off of it using the Olin bit. So, that's my take on that. I can't think of much else. I got other stuff in the shop that's probably not the norm. My homemade dust collector cutoffs, but I can't get one of them down right now. They work real good. Oh, my son's here. I'm going to have to quit. They say the Olin tool can't cut. Look at these strings. That look like it's cutting or not. And that's Bubinga. That's hard as a rock. Like I said, I'm going to keep this video really short. Probably a lot of things I should talk about, but I can't think of anything right at the moment that I really need to talk about. I got all this stuff laying around. Did this for a demo. It looks like Jatoba and Yellowheart. Just glued up as a demo one time. Club me and show how fast you can glue up segments. And this one here I did as a demo too. I did this to show the difference between closed segments and open segments. The difference in the cut length and the difference in the angle. They're both the same diameter ring, but there's a big difference in the segments of them. I don't know what I'm going. I got more of this stuff laying around the shop. I know what to do. I got too much wood laying around. I think next I'm going to do a little turning. I want to do a turning using some really beautiful, expensive woods. I want to use Bubinga. I got some nice Bubinga here, which is really a good hardwood, really pretty wood. And Cocobolo, I got some nice dark Cocobolo. I want to combine them. I'll make a little turning Bubinga and Cocobolo, and I want to do it to show how well the turning tools work, and also on sanding it again. And like I said, the sanding depends on the woods. Some woods you just can't sand too much, you sand them all away. Well, even the hardwoods, if you got a softwood and a hardwood together, you can't sand too much, you got to turn them pretty good. And as for turning tools, no matter what tool you use, they all do the job. The correct tool to use for a segment turning or an open segment turning is really the one that is least dangerous for you to use. And that's normally the one that you know how to use. So it don't matter what you use. I'm just showing you, what I use. And the reason I use it, because when I started turning, I didn't have money, and I had to have something that was cheap. And boy, was that cheap. And it cuts just as good as anything else. I don't care what they say. It works just as good. And I use it all the time. So I'm going to stop this video here. I know I'm going to catch a lot of grief about it, but I'm going to stop this video here. And like I said, in the next video, I think I'm just, for kicks, going to make a turning from Bubinga and Cocobolo. Put a Cocobolo bottom on it, a floating bottom. Put a Cocobolo ring on the top. So if you got any questions or you got anything you don't agree with, I'll leave my email up here. And please come back and see my next video. Thank you.